Welcome to Chibuzor Mathphysics. In today's video, we are going to continue with the Newton's interpolation. Here we've got a question. The population of a town around Tangaza University is given by the table below. Just before we continue, always remember to comment and subscribe. So the population of a town around Tangaza University is given by the table below. And the year is in 1951, 1961, 1971, 1981 up to 1991, and the population is in thousands. So we have got 19.96 up to 1994.61. So using Newton's forward and backward interpolation, calculate the increase in the population from the year 1955 to 1985. So the first thing to do in this question is we have to first form the finite difference table. So when we form the finite difference table, we shall use 1955. Of course, 1955 will be for our forward difference table, and 1985 will be our backward difference table. So let us form our table, and from there kick off the computations. Welcome and remain blessed. Galagash. So using the year and the population in thousand to form our table, we will have x, we have x, and then we have y. For x, we've got 1951, so this will be 1951. For y, 19. For y, we've got 19.96. 19.96. We've got 1961, and here it is 39.65. So now, after we might have write down our values in this difference table, this is for x, the year is for x, and we take population, which is in thousand, to be for y. So the differences will be 39.65 minus 19.96. That will give you, if you plug that to your calculator, you will simply have 19.96. So we write it in the middle of this, so 19.96. Let's take this difference, 58.81 minus 39.65. That will be 19.16. So this will be 19.16. If we take this difference, we will get 18.4. This is 18.4. Let's take 19.61 minus this, we will get 17.4. So this is 17.4. Okay, and this is our first difference finite. So this is our first difference, so we write it first difference. So this is our first difference. Let's take the second difference. The second difference will be this 19.16 minus 19.96. This will give us a negative 0.53. Negative 0.53. If we take this difference, we will get a negative 0.76. This will be negative 0.76. And if we take this difference, we simply get negative 1. Let's take the fourth difference. This is the third one, the third difference. The third difference, we will get the difference between this and this. This will give us a negative 0.23, and this will give us negative 0.24. And finally, the fourth difference finite will be, if we take this difference, this minus this, we will simply get negative 0.01. negative 0.01. So this is what we have now. We need to find the first case. We need to find y of 1955. That is the forward difference interpolation. So we are going to use this for our forward difference. So we are going to use the first one to find y at 1955. Let us do that. So now for the first case, we need to find y at 1955. So to do this, we need to use Newton forward interpolation difference table. So interpolation. So let's use Newton forward interpolation. So Newton forward interpolation formula will be given by we know that yp, or what we call the function f of x. We can start with the function f of x. This will be equals to y naught plus we have p. Of course, some people use r, p into this first forward difference plus we have p into p minus 1 divide this by second factorial. This is into the second forward plus p into p minus 1, p minus 2. This is into the 3 factorial. Of course, this is the third forward difference plus we have p into p minus 1, p minus 2. Then we have p minus 3. Divide this by the 4th factorial and multiply by the 4th forward difference. Okay, so this is what we have now. So now let us find the value for p. So p will be given by x minus x naught divided by h, and this is equals to x is given to be the first forward difference, that is 1955. So it will be 1955 minus x naught is this first value, and the first value is 1951. So it is 1951. This is our x naught. We plug it here, 1951. Divide this by the interval, equal intervals. So if you check what is the equal interval between 1961 to 1951, it will be 10. So divide this by 10. So if we do this, our p will be equals to 0.4. So now we use this to find the y of 1955. So now for the Newton forward interpolation formula, we are going to use the first column, the first leading column in this table. This will be our first leading column in this table. So we'll be calculating with this first leading in the first forward. So we are going to use this to plug in into this formula. So let us do that. So our y of 1955 will be given by y naught is 1996. Y naught is 1996. So this is 1996 plus p. Our p, we got 0.4. So this is 0.4 into the first 0.4 into the first forward difference, and the first forward difference is 1996. So multiply by 19.96. So we do this. This is plus. The second one will be 0.4. We have 0.4 into 0.4 minus 1 divided by 2 factorial multiplied by the second forward difference. So let us add all of them together. So when we plug in all our values in this given formula, what we will get is, using that is y of 1955 will simply give you 27.89. When you plug this into your calculator, of course, you multiply each of these with the forward. Here we multiply with the second forward difference, the third forward difference, and the fourth forward difference, which is negative 0.01. We are using this. This is our first forward. We have the second forward, x naught, first forward, second forward, third forward, and then the fourth forward. So now let us also calculate the 19 to find y of 1985 for the backward interpolation. Note now that for the backward interpolation, for Newton backward, our formula changes. Here we will have yn, not y naught. So this is yn plus p into we will have n plus, this one become plus, and it is plus 1. Then we have plus 1 plus 2 into 2 factorial. We have plus 1 plus 2 plus 3 into this. We change this to n because this is backward difference. We change that. So this is the formula for backward. The difference between Newton's forward is that in Newton forward we use negative, but in Newton backward we use positive. So pay attention to that. So plug in that into the given, plug in this value into this equation, but remember that now we are doing backward. So our backward will be from here. So we take this to be our backward. So Newton backward will be calculated using this. So let us plug in these values in this formula to determine f of 1985 for Newton backward. The thing we need to do here now is to find the value of p using the Newton backward formula, because the value of p here that we got 0.4 is only for Newton forward. So let us find the value of p using Newton backward. The value for p for backward will be given by x minus xn instead of x naught. Divide this by h. And for our x, we are calculating using 1985. The other one was 1955. So 1985 minus the first is 94.61. So we use this 1991. So 1991. This is our xn. Our xn 1951. Divide this by 10. And when you divide this by 10, you will get it is equals to negative 0.6. So we plug in this now in this formula for backward, and let's see what we will get from there. So when we plug in this into this formula using the Newton backward, of course we are multiplying using the Newton backward. So we multiply each of these with this is the Newton first backward 70, 4, which we multiply here initially 17.4, and at the end we will simply get